So, dito na tayo sa regenerative cycle. So, ang regenerative cycle class, if the reheat had two turbines, dito, in a regenerative cycle, we have a boiler as well as turbine. Papasok na dito kasi yung tinatawag na open feed water heater and the closed feed water heater. Okay? Kung sa reheat cycle, palaging 1 kilogram mass ang entering in each components of the cycle or each part of the cycle. Dito class, may tinatawag na tayong fraction of steam extracted. Okay? Papasok na yung M natin dito. Okay? Yung mass natin leaving the turbine that is going to the open or the closed feed water heater. Dito yan, class. Dito, sa open feed water heater. And yung some part is entering the turbine. Okay. So, bakit nga ba kailangan natin ng regenerative Rankine cycle? Okay. So, we raise the temperature of the liquid leaving the pump. Yan. Itong pump number 2 natin sa figure. So, this is just an example of a regenerative cycle wherein this is an open heater. Take note, open heater. So, yan muna yung pinakita ni ma'am kasi mas madali yung TS diagram ng open heater. Okay. Balik tayo dito sa schematic. So, kailangan natin ng regeneration dito kasi we need to transfer heat to the feed water from expanding steam in a counterflow heat exchanger built in the turbine. Okay? So, ang tinatawag dito kasi yung practical regeneration process wherein in all steam power plants, ini-extract natin or the extracting or bleeding na tinatawag. Yan na, baka ano yung naisip nyo. Extracting or bleeding steam from the turbine at various points. So, dito yan, class, from this turbine, sa turbine natin, hindi ko na-zoom. Hindi pala ito PDF. Okay. So, yan, sa turbina natin. So, we need to produce more work by expanding further in the turbine. So, we use to heat the feed water instead. Okay? Yung feed water dito kasi sabi ko, from the turbine, high pressure, high pa din yung steam natin. So, mainit pa yung temperature din natin, higher temperature. Nangyayari sa turbine natin. So, ginawa itong device, or yan na tinatawag nating feed water, is heated by regeneration. Yan. Regeneration yan, class. Ang tawag na dyan is the regenerator or yung feed water heater natin. Okay? Regenerator or feed water heater. Or makikita nyo sa mga symbol, yung feed water heater natin is always FWH. Okay. So yung regeneration, class, it doesn't only improve cycle efficiency, but it provides a convenient means of derating the feed water or tinatawag natin removing the air that leaks in the condenser. Okay? Dito class sa condenser natin ha. Di ba sa simple Rankine cycle natin, we have the boiler, turbine, condenser, and the pump. Dito, dagdag na tayo ng dalawang pump. Okay. So, ano nga ba class ang open feed water heater? Yan. An open feed water heater is basically a mixing chamber. Yan. Direct contact yan, class, ha. Where the steam extracted from the turbine, dito, class, from turbine, we have number 2, and we have a mass of M considered. So, that is now stream extracted. And it mixes with the feed water galing dito sa pump 1 natin. Yan. So, this is now your open feed water heater. So, sa process, class, ulitin ko lang, from the boiler, the steam is heated at a higher pressure. that will cause our turbine to generate electricity, or the turbine shafting to move, that is connected to a generator wherein we can now produce the work of the turbine. After that, the steam is extracted at the some portion is extracted to the open feed water heater, and some of it is extracted to going to the condenser. So take note, the entering mass at turbine is 1, and while the mass leaving the turbine on the that is going to open feed water is considered as letter M, or denoted as M, mass of steam, and the mass of the steam going to the condenser is considered as 1 minus M, or denoted as 1 minus M. After that, yung condenser natin is connected to a pump. Yan, same pa rin class dito yung ano natin ha, yung mass from 4 to 5. After that, papasok na dito sa feed water. So sa feed water, since this is an open feed water, magmi-mix ulit yung na-extract nating turbine, na-extract nating mass sa turbine. Okay? Magmi-mix ulit sila dito sa open feed water, so balik ulit siya sa 1 kilogram. Considering na 1 kilogram mass yung mass natin. Okay? And going back to the boiler. So, dapat alam niyo na yung processes natin dito, ha? Or energy balance during the cycle. Ayan. So, this is now the TS diagram. As you can see, from process 7 to 1, that is the boiler. Dito yung class, nakalimutan ko yung 1. Ayan, sulat natin dito yung 1 kilogram mass entering. So, this is 1. Ayan. Considering that is a 1 kilogram mass. Okay? So, after that, dyan ka na sa 1 kilogram mass. Entering. Process 1 to 3, nangyayari na dito kasi yung sabi ko nga, pumupunta sa open feed water. So, denoted as 2. 2 to 6 is where your feed water, and 3 to 4 is the condenser. Yan. Sulatan natin para hindi kayo malito. So, 4 to 5, babasahan nyo to dito class sa schematic diagram natin. 2 to 3 is your yan, separate process wherein yung mass natin papasok sa dito class papasok na yung sa open feed water heater natin. And 3 to 4, yung condenser natin. Bakit class ina-explain ko yung TS diagram and the schematic? Kasi mas maiintindihan nyo yung problem or a certain problem pag kaya nyong i-draw yung schematic and the TS diagram of the process. Not necessarily kung sinabi class sa problem na superheated, kung nalaman natin na superheated yon, pwedeng dito pa yun sa labas. Ganito class. Ayan, considering superheated, ayun, palubat na ba ako? So, pwede din class sa labas. Okay? Pwede yan mangyari na dito yan sa labas. Depending upon the given state points or the given mixture or the given, yes, parameters in the problem. Okay, pwede yan class. Pwedeng mangyaring superheated yung steam natin from 2 to 3. Okay? Mangyayari, if that is 2, paganyan din sila. Considering superheated, 1, 2, and if this is 3, straight muna dyan class, pag when you draw the TS diagram, under the TS diagram, yung from when it is a constant pressure, pag sa loob pa, straight pa, kasi pero pag superheated, saka ka mag-aslant. Ayan. This is now year 3. So, considering na superheated yung steam natin. And 4 to 5, we have the work of the pump, and 6 to 7. So, we have now pump 1 here. So, ayan. It's pump 1. pump 2. Ayan. So, dalawa yung magiging work of the pump natin. And process 7 to 1, yan. Yan yung boiler natin. Ay, wait, class. It's now your boiler. Yan. So, ganyan class pag open feed water, considering yung mass extracted na M, yung M natin, and the 1 minus M. Okay. So, this is now the cycle analysis. Yan. On the basis of a 1 kilogram of throttle steam. Ayan. Yan, class. So, magkakaroon na tayo ng mass balance. Kung dati, energy balance, we have now the mass balance. Okay? Considering, ano tayo? Pupunta tayo doon sa open feed water heater. So, pag open feed water heater lang to, class, ha? Yan. Mas madali isolve to, class, na open feed water heater. So, energy balance, entering mass is equal to the mass leaving the system. So, from here, diba, class, dito, sa taas, ito yung kino-consider natin, class, ha? Ditong part. Ito, class, na part. The open feed water heater. Yan. Entering natin na mass is the M, ito, plus the 1 minus M is equal to 1 kilogram. Kung yan yung magiging basis natin. Okay. Papasok na class yung energy balance natin. So, all entering energies is equal to all the leaving energies within the system or the component. So, since the consideration now is the feed water heater, ayan, we have the MH2, to class, MH2, and plus 1 minus M, H5. So, ito class yung entering natin, ha? Entering. Ayan. Lapit-lapit lang. And the leaving energy now is equal to the 1 kilogram of the enthalpy at 0.6, given yung parameters natin. Okay, simplification, we have now the mass of the bleed steam. And this is now the mass of the... Kasi sabi ko nga, that is either extracted or bleed. So, yung regeneration process natin in steam power plant is accomplished by extracting or bleeding the steam from the turbine at various points. So, this is now the mass of the bleed steam. Okay? So, yan muna class yung hahanapin kadalasan when the process is undergoing a regenerative process or regenerative Rankine cycle. Okay? So, the heat supplied now, considering 1 kilogram, so equal naman siya class in the boiler. So, H1 minus H7, energy balance lang. In the turbine work, ayan na, malami-lami. So, considering yung 1 kilogram natin, highlight na lang tayo. Okay? In a 1 kilogram, so entering natin from the turbine, we have 1 kilogram. Ayan. This is now our consideration. And the extracted and the bleeded steam, we have the MH2 and the 1 minus H plus 2. And the energy leaving the system, we have now the work of the turbine. And simplification, the work of the turbine now is equal to H1 minus MH2 minus H1 MH2 minus 1 minus MH3. Yan. So, distributive property, 1 minus H3, negative times negative, positive na yung magiging MH3 natin. So, we have now H1 minus H3. Ito na class. And the M now is, factor out mo muna. So, kinuha yan dito. MH2 and the MH3. This is now addition. Okay? Ayan. Bakit mo may mga ganyan? take note, the work of the turbine. Pwede naman to, class. Pwede naman to. We can go for that. But since in the, sabi dito, or. Ano to, class na or? So we have now H1. Naririnig ka, class. H1 minus MH2. Ayan. So, binalikan ko lang dito sa task class. Yan. Yung asterisk natin. Palitan natin yung color. Ayan. Good morning, sir. So, H1 minus MH2. So, binalikan doon sa taas. Minus 1 minus MH3, the quantity. So, we infuse this, the H2. Ayan, class. The H2 minus H2. So, this is just considered as 1, di ba? I mean 0. Di ba, class? Naintindihan nyo? In-infuse lang natin to dito sa equation. Ito. To make necessary adjustment. Ayan. So, nilagay siya dyan, class. So, kinonsider yung 1 minus H2. Dito na. And M, H2 plus H2. Ayan. Cancel lang naman yan, class. So, 1 minus M. 1 minus the quantity, 1 minus MH3. Yan. Proper. Finactor lang to, class. Na ito, na part. Ito na siya. So, karoon na ng 1 minus MH2. Ayan. So, we can make use also this equation, derived equation. Ayan na. So, galing siya dito, yung H2 and H3 natin, 1 minus M. And ang i-consider lang natin dito is yung H1 and H3. So, we can use both equation kung alin kung saan kayo mas convenient. Or, in the problem, what is the given mass of the bleed steam? Okay. So, this is the derivation of turbine work. And in the heat rejected, since meron na tayong extracted steam, so this is now 1 minus M. Energy equation, we have now entering the 1 minus MH3, which is equal to leaving the heat rejected at the condenser as well as the same bleed steam, or the 1 minus M times the enthalpy at 0.4. So, this is now the heat rejected. We have 1 minus M, H3 minus H4. Okay? Ayan, H3. We move on to the total power pump. Total pump work. Okay. Sabi ko kanina, in a regenerative, we have two pumps. Yan. We have pump at 0.1. So, from the condenser to the open feed water, that is the pump wherein the pump 1 is located. And after the open feed water to the boiler, we have another pump located. Okay, so the total pump work now is this one. So, we have the summation of the pump work from 0.1 to pump at the first location, the pump at second location. So, we make always use of the approximation of the work of the pump, wherein the specific volume saturated liquid is always multiplied by the pressure at certain point, or the pressure from the open feed water to the condenser. And the work at pump 2, we make use of the specific volume at saturated liquid that is multiplied also to the pressure at the boiler minus the pressure at the open feed water heater. Okay? So, this is the equation that is usually used, but since this is an approximation, and Ito po class yung ginagamit kadalasan sa pag-compute when computing for the total pump work or the any given regenerative Rankine cycle. So, the summation of the work of the pump, to make, gagamitin na natin to. So, sa TS diagram natin, ano yung pump natin, ditong part. Okay, so this is now your sa feed water heater. Ayan. Ayan, dalawa yan sa boiler. So, this is from the condenser. Ito yung sa boiler natin. So, this is 0.7, this is 0.6, and this is tama ba? 5, 4, 4. So, this is 5, and this is 4. So, the approximation now of the total pump work. So, hindi na tayo magdadalawa-dalawa pang i-compute. So, gagamitin na natin is from condenser to the boiler. Okay? So, ito na yung hinahanap natin. We have now the saturated liquid. The specific volume at the saturated liquid multiplied by the pressure at the boiler. So, boiler to class minus pressure sa pump natin or the first pump. Okay? Yan. Kung ano yung nangyayari doon kasi constant pressure naman nangyayari. So, that is the pressure also from the condenser. Okay? So, that is now the approximate total pump work in a regenerative Rankine cycle. And using the necessary equation or from equation derived from the work of the pump and the total pump work, we can make use now of the total or the work net in the system. May kulang akong nasulat. So, minus work summation ng work ng pump. Plus pakitingnan niya dun sa PDF na nasend ko. May kulang. So, this is work net. So, ito yung ginamit na equation natin from the work of the turbine H1 minus H2 plus the 1 minus M H2 minus H3 minus the quantity or minus the summation or the approximate total pump work. Ito. Kulang to class dun sa nabigay ko. Ayan. And finding for the thermal efficiency, we make use of the work net over the heat added. So, pwede naman to class na 1 minus the QR over the QA. Ayan. Kasi once na dinerive mo naman siya, mag-equate lang naman to. Okay? Pero ito kadalasan ginagamit natin. Ayan. Work net over the heat added. So, sa heat added natin, sa boiler lang yan nangyayari. Okay? So, this is the derivation on an open or in a given open feed water heater. So, ito yung kadalasan hinahanap. What is the mass of the bleed steam? When we say the bleed steam, it is located at the open feed water. Okay? The energy equation or the energy balance that is needed to solve for the problem, the given problem, in a regenerative cycle is always located at the open feed water heater. Take note, pwedeng maging superheated yung 0.2 natin and 0.3 depending upon the given state points. Okay? Excuse me. Okay. So, this is now the open feed water heater. Okay? Punta tayo dun sa closed feed water heater. So, if the open feed water is not complicated, kasi ang open feed water heater natin is basically a mixing chamber where the steam extracted from the turbine mixes. Ayan, dito sa open feed water. So, it mixes with the feed water exiting the pump. So that is the first consideration in an open feed water heater. Yan, so makukompute natin yung mass of the bleed steam.